Hello friends, let's solve another LeetCode problem, sorts in rotated sorted array. So as the name suggests, our input will be a array which may or may not be rotated at a unknown pivot index, and we'll have a target, and we have to determine whether our target exists in the given array or not in minimal time in with a runtime complexity of big of log n. So let's see a few examples. Our input array is 4567012 and target is 0. So as you can see, the array is pivoted around index 3, 0, 1, 2, 3. So split if we'll split the given array into two parts, then our individual sub-arrays would be sorted array. And since our individual sub-arrays are sorted, we can use binary search to determine whether our target exists in the given sub-array or not. And similarly, we can apply the same binary search to determine the pivot index. Note here ideally in a sorted array, all the n plus 1 element would be uh, higher than the nth element. But in case of pivot, the n plus 1 element will be less than the nth element. So we'll use that logic to determine the pivot first, and once we have the pivot, then we'll check on which side of the pivot our target might be, depending on the uh, uh, s- individual subarrays low and high. That is the initial and the last element of the individual subarray. So let's start. I'm writing a method get pivot, which will have the similar inputs, but instead of target, we'll have a low and we'll have a high, which would be the low and high index of the given array, and it will return an int, uh, the index of the pivot index of the given array if the list is pivoted. So let's write some exit conditions. If in ideal case our low should be less than high, but if our low is greater than high, then I will return -1. That means our array is not pivoted. Again, we'll write another case. If low equals to high, in that case, uh, let's return low for now. Uh, Wait a second. If low equals to high, we have only one element in the array, and it cannot be rotated since there is only one element. Since in that case, we'll also return -1. We'll put a print here so that we'll be able to debug it in once we run it. Now let's calculate the mid. Same similar way as we do in binary search. So mid will be low plus high. I'm using floor division 2. So if floor division 2 gives us a integer even when our result would be a float. For example, if in this given example we have 7 elements, so 7 by 2 is 3.5, but with floor division we'll get 3. Now we have the mid element or the mid index. So let's compare the mid element with its neighbors. So in the first case, we have 4, 5, 6, 7, and the mid element is 7. So let's compare mid minus 1 and and mid mid plus 1 to check which one could be a pivot. If low less than mid and norms mid minus 1 is less than norms mid. In ideal case, our norms mid minus 1 would be less than mid, but if it's not the case, I'm changing the operator here. So in that case, we'll do return mid minus 1. Similarly, we'll check the other case. If our mid less than high and we'll compare mid and mid plus 1. So on ideal case, mid plus 1 would be greater than mid, but if our mid element is the pivot, in that case our mid will be greater than the mid plus 1. In that case our mid will be the pivot element. For rest of the cases, let's see this example. So in this example, we have 0, 1, 2, 4, 5, and we have 6, 7. So our mid element is 1, which is in sorted order corresponding to mid minus 1 and mid plus 2. But if we'll compare the mid element with the zeroth element, with a low element, so we'll get to see that our low element is greater than the mid element. So we can write if low less than mid and norms low greater than norms mid. In this case, our pivot is present on the left part of the mid. So that would be low till mid minus 1. So we'll return self dot. We'll call the same method get pivot. Get pivot will pass norms. Will pass low. Will pass mid minus 1. And for rest of the cases, it would be on the right side of the mid element. So mid plus 1 till high. Now that we have the pivot, let's print the pivot and check whether our pivot method works as expected or not. Self dot get pivot. First is norms, next low element would be 0th index, and the next highest element would be length of norms minus 1. Print pivot and our pivot element. So let's put few checks here. So if our pivot is minus 1, in that case the element is the array is not rotated. So we'll do regular binary search here. and uh, we'll we'll do regular binary search of the given element, and just for sake I'm here putting pass here, and we'll do a test of this pivot method, and I'm writing a return 0. We have indentation error, mid equals to low, and we have a similar indent error. Let's see output 0, expected 4, and it's printing pivot at 3. In all the cases, we have the same rotated array, and in this one, our return is -1, pivot at -1 means it's not rotated. And let's write the binary search method now. So we'll do dep binary search. So binary search is a standard method to take self, norms low, high, and target colon int, and return int. In our binary search method, we'll put exit condition first. So if we'll put the same thing, if low equals to high, return -1. If low equals to high, we have a single element. In that case, we'll check return -1 if norms of low will return low if norms low equals to target, else will return -1. For rest of the cases, let's calculate mid, where mid will be low plus high by 2. I'll just reuse the same thing here. And once I have the mid, I'll check if low less than mid and norms low norms mid greater than target. So this is a sorted array, and if our norms mid is greater than the target, then our target would lie on the right side of the sorted array. We'll return self dot, again binary search, pass on norms, pass on uh, mid plus 1, since it would be plus 1 till high, and the target. For the other part, let's write in the last case. If none of the above condition matches, then we'll search from low till mid -1. Now that we have our binary search method and we have our pivot method, let's write the other cases here. Here we'll do return selected binary search norms low, and our high would be length of norms -1 and target, and we have a detail, so we no need the pass now, no need the return 0. If now let's uh, check the pivot element if it matches with the target. Norms pivot equals to target, then return pivot. On the other cases, if norms low is less than equals to target and norms pivot. So what we are trying to do is since we do not find the target element yet, we are splitting the given array into two parts. Uh, so norms of low, or we do not have a low here. So norms 0 till the pivot, norms 0 till the pivot, and the other part would be pivot plus 1 till the end. So if norms 0 less than target and norms target is greater than norms 0 and less than norms pivot, in that case return binary search of the elements on the left sub array, that would be our 0 till pivot and target. And for the other case, let's write it in the last binary search pivot plus 1 comma length of norms -1. Looks okay. Let's run and see if it matches our name low. Okay, it would be 0. My mistake. 4, 5, 6, 7. Our output is -1, expected 0. We're returning pivot 3, expected 4. We'll debug. We might have made a mistake somewhere. Because of that, our output is -1. Uh, okay, let's see. We are getting only pivot 3. So pivot is 3 and our target is 0. Target is 0. So pivot equals to -1 is not the case. Norms pivot norm is not the target. It's not the case. Norms of 0 is 4. 4 less than equals to 0, correct? And norms of pivot index is 3, so norms of 3 is 7 is less than target. 7 is actually greater than target. In that case, it would be 0 till pivot. For rest of the cases, it's okay. Let's retest. on the binary search here we made a mistake. Let's correct it. Actually, target we have mentioned target less than mid. Actually, in case of target greater than mid, our target would lie on the right side part of the sorted array, which would be mid plus 1 till high. And in case target is less than mid, then our target will lie on the left part of the sorted array, which is low till mid minus 1. Let's retest. Have all the test cases succeeded. So here is our final code to sort the given element in a rotated sorted binary array, rotated sorted list. Thank you for watching.